All right, so in this little video, hopefully it's little, I want to work through the window example that they gave a picture of in the slideshow. So I'm going to start by reminding you of the picture and the geometry. So here's the story. We have a window. The height of the window is 2 meters. So, and then there is a cylinder, a piston cylinder, that is attached at the midpoint. So it's down 1 meter from the hinge on the window. Okay? And they're calling this angle at the top theta. And they're calling the length of the piston S. Okay? So theta is going to be the angle at the top of this triangle. I have side length 1 here, and I have side 2 meters there. All right, let's switch over to my iPad and let's solve this one. So the window example, the basic picture that I have is okay. So I have a triangle here. I have an angle theta at the top, and the this distance is 2. Oh, apologize. Go back. This distance is 2. This distance is a fixed length of 1 meter. It's a big window. And this distance here is S. All right. All right. And what we want is to relate S to theta. So we want, eventually what we want is an expression for, I just worked out omega. You could find alpha too. Just got a little tired. So we want an expression for omega in terms of theta and S. Right? So because so in terms of theta and S, so we'll have a formula that could vary, you know, as you change the length of that cylinder, that piston cylinder, the angle will change. So these can be a little complicated. What helps me sometimes is to look at limiting cases, limiting angles and limiting distances, so that I have a few values that I can plug in and know the right answer. And that kind of, I can use that to kind of check expressions in the middle of the calculation so that I don't proceed too long and you know, with a minus sign mistake and have it go sideways. And believe me, you can have minus sign mistakes. The algebra in these things can be a little bit gross, but that's okay. All right, so what if I look at this diagram? What I notice is, maybe I'll go ahead and extend this down. The rest of the window extends down. Oh, come on. There you go. An extra, over here, 1 meter. That's really not going to have anything to do with the problem. So when the window is fully closed, so when the angle is 0, I know that S equals 1. So think about that. If you lower, I guess it's backwards for you guys. When the window lowers all the way down, okay, so it starts out and then it lowers all the way down to be vertical, the angle is 0, and S would be attached halfway up the window, so it only have a length of 1. So I know that when theta equals 0, that should correspond to S equals 1. Similarly, when theta equals 180 degrees, so when the window is wide open, vertical, flush against the wall above the window, then S should equal 2 plus 1, or 3. So when theta equals 180, that's going to give me S equals 3 meters. That helps me sometimes if I'm not trusting that I've got minus signs right? So I've already seen that sometimes I think there are some issues with whether they call clockwise angles positive, and they kind of, usually they get the final answer right for the velocities of things and the positions of things, but I think sometimes the angular quantities, it's a little touchy if the minus signs are quite the way, at least I would have done it. So to make sure that my formulas are good, it's helpful to have a couple points to plug in and know that it's right. Good reference values. Okay, so I'm going to draw this triangle again, and we're going to try to come up with some equations that we can use. Now, this is maybe a little different than the way I do some of these might be slightly different than how the book does it. It all amounts to the same thing, just sometimes. Okay, so I'm going to redraw this. And we've got an angle theta up here on the top. Got a distance 2, a distance 1. And so there's not one way to do algebra. I oftentimes like to give the angles a name, and I find that it helps me organize my thoughts. So there's an angle. There are 3 angles in this triangle, but the one I'm really interested in is this one. I'm going to call this phi. So I have angles theta and phi. Now, what I'm going to do, and then I'm going to break this triangle into 2 right triangles, like that. Now, I can look at that triangle, and I can relate various quantities. So you can either say you're using the law of sines, or you can just say that at the attachment, the place where the rod is attached, the x positions have to be the same, whether you view it from the kind of the hinge down, or this piston cylinder value, x value of that point. But I'll say use the law of sines here. So the law of sines on this larger triangle states that let's see, and I have distance s there, states that sine of theta over s must equal sine of phi over 1. Okay? That's kind of a useful formula. And then also from this triangle, I know that if I were to add up the vertical part of this small triangle plus the vertical part of the medium triangle, they have to add up to the vertical component of the large triangle, which is 2. So I get the following equation. I know that 2 must equal 1 cosine theta plus s cosine of phi. Okay? And in case you're worried about positive angles and negative angles, at this point it doesn't matter, for that one at least, because the Cosine is an even function, so it doesn't matter about the sign of the argument. Okay, so those are my two key equations. And then after that, it's really just a lot of arithmetic. One observation. That phi is always going to be, it's going to range, it certainly is between 0 and 90 degrees. Okay, so phi is going to never exceed 90 degrees. And what that tells me is because phi is never greater than 90 degrees, it tells me that cosine of phi is always positive. And that's really the fact I'm going to use here. So because cosine of phi is always positive, it's actually strictly greater than 0, but that's okay. Then I can actually rewrite it. I can use the Pythagorean theorem to give me a different expression. So I can say that cosine of phi actually equals the square root of 1 minus sine squared of phi. And that's okay as long as cosine of phi is positive. If it was negative, I'd have to choose the other root. I'm just using the Pythagorean theorem. 1 equals sine squared plus cosine squared. But going back to the previous page, I have a nifty little formula for sine of phi. Okay, so I have this formula for sine of phi that it is equals sine of theta over s. So wherever I have sine of phi, I can replace that with sine of theta over s. So my second equation down here, I can now look at this equation, which originally had a theta and a phi, but I can eliminate phi in terms of theta as follows. So I have 2 equals s cosine of theta plus 1 times cosine of phi, which is just going to be the square root of 1 minus sine squared phi. But sine squared phi is nothing other than sine squared theta divided by s squared. Oh, I've got my links in the wrong spot. Sorry, transcription error. Let's go back there. So it happens when you toggle from one page to the next. Okay, so all I'm doing is writing this equation out. I've got 1 times cosine plus s times cosine of phi, and then I'm using this expression for cosine of phi. So 2 equals, now let's fix it. That's going to be cosine theta plus s times the square root of 1 minus sine squared theta over s squared. Don't forget to square everything. And you can clean this up if you want. So this would become, well, here's what I'm going to do. I'm going to write this as 2, let's get rid of the square root. Let's write this as 2 minus cosine theta squared equals, so I'm rearranging it and squaring both sides. And I'm going to get s squared minus sine squared theta when I square both sides. Distribute and square both sides. So I've moved this inside and multiplied everything by s squared, and then I reordered it and squared both sides to get that result. Um, oh, I don't know. I don't know what, is it worth? Sure, we could write it, expand it out a little bit more. I could write this as, oh, I would get a cosine squared theta from there, yep, cosine squared theta minus 4 cosine theta plus 4, I've done that right, equals s squared plus sine, sorry, minus sine squared theta. And then I can combine sine squared and cosine squared to just give 1. So I'm going to get 5 minus 4 cosine theta equals s squared. Okay, so let's check. This is where it's useful to see if I missed a minus sign. Maybe you have and you've noticed. So let's go back. And what were my reference values that I wanted to check? When theta equals 0, s should be 1. And when theta equals 180, s should be 3. Let's check that. When theta equals 0, so when theta equals 0, cosine would be 1. This gives me 1. So s could be 1. When theta equals 180, then cosine of theta equals -1. So I get a double negative. This becomes 9 equals s squared. S equals 3. We'll solve the equation. So that's good. This matches my limiting cases. So this is consistent with saying that theta equals 0 implies s equals 1. Theta equals 180 implies s equals 3. The limits of the right on the crack of an eye in the iPad. Okay, so I can be pretty confident that I haven't fouled this up too badly. All right, all that remains then is to do the calculus. So all I have to do is take this formula and take its derivative. All right, so I take the derivative. I have to take the derivative of this quantity right here on both sides. Maybe I'll rewrite this on the next page and then take this derivative. So I'm going to get, so start with 5 minus 4 cosine of theta equals s squared. So now I'm going to take the derivative on both sides, and that's going to give me, so first derivative. The first derivative is going to give me minus 4 plus 4 sine theta times theta dot, which I'll call omega, must equal 2s s dot. And we get the following relationship that omega equals s dot over 2 sine theta. So that's the relationship between the length of the piston cylinder, the rate at which it expands, and the angle and the angular velocity that it swings open. Okay, so hopefully that was an illustrative or an illustrative example. I think, at least in the slides, the book doesn't always introduce that second angle phi I find that it helps me to kind of to label things a little bit more and work it out. So, okay, I'll see you guys during class time.